Hi, everybody. For our lesson today, we are going to be taking a point on our coordinate plane, for example, 5, 0, and we are going to be rotating it about the origin. So rotating it around with the origin as kind of our vertex or axis, and our point is going to be traveling somewhere around the circle to a new point. Now, we talked about rotations when we did our transformations unit, but those rotations were strictly by multiples of 90 degrees. So we rotated 90 degrees, 180 degrees, and 270 degrees. This is going to be by non-90 degree numbers. So as I said, we're going to start off with a point at 5, 0. I'm going to call that A. And when we are going about the origin, and our point is starting on an axis, so it could be the x-axis or the y-axis, that automatically gives us our radius because our point is going to travel in a circular motion, so it's going to be the same distance from the origin at all times. So from the origin to A, our current radius, or the radius for this problem, is 5 units. So as we rotate around the circle, that distance from the origin to the point, no matter where it ends up, should always be 5 units. So for this first problem, we are going to rotate 50 degrees. Now we want to remember that our origin, the intersection of our x and y axis, that is perpendicular. That location is perpendicular. So the x-axis and the y-axis make 90-degree angles. So if we traveled all the way to the y-axis at the top, that's going to be 90 degrees. We're not wanting to go that far. And we also must remember we are going to always travel counterclockwise unless our problem tells us otherwise. So the default is counterclockwise. So we are going to rotate 50 degrees. So I'm not going to quite get all the way up to the y-axis, but it's going to be a little bit more than halfway. And this is just an eyeball. It does not need to perfectly be 50 degrees. We're not going to use a protractor, a compass, or anything like that. We're just going to eyeball where 50 degrees might be. And so I'm going to go halfway and just a little bit more and put a new point there. That new point is going to be called A prime. So it's going to notate we took the point A and we moved it. And that's going to find a new X and Y value. We're going to have to find a new X and Y value. We don't know what they are yet. As our point rotates, we remember that from the origin to our point, the radius is going to remain as 5. So we now have a length of 5 known in our problem. As we stated, we rotated 50 degrees. So from the origin, I rotated up, from the x-axis, I rotated up 50 degrees. So I have 50 degrees in that angle that is formed from the x-axis and where our new point A prime is. From here, we're going to create a right triangle because we can do all these fantastic things with right triangles. We can do trig, Pythagorean theorem. We can use our special right triangles. And so we're going to make a right triangle so we can use one of those tools. From that point A prime, I'm going to drop an altitude down. That is going to be parallel with the y-axis. And that is going to give us a place on the x-axis for our x value. So now our radius from the previous A point can go away. And from the origin to that altitude is going to be our x value. Wherever the length of that line segment is going to tell us where the x value point is. That vertical line that's running parallel to the y-axis is going to give us our y value. So now we have a right triangle. And from this right triangle, we can choose to do Pythagorean theorem, special right triangles, or trig, depending on the information we have. So going through my right triangles toolbox checklist, I know one side length. So I know I can't do Pythagorean theorem because I would need to know more information unless I knew this was isosceles or I had some additional pieces. I have an angle of 50 degrees, so it's not one of my special right triangles. So instead, I'm going to have to use trig. So in order to do that, I need to figure out, am I using sine, cosine, or tangent? You may want a little reminder off to the side of SOHCAHTOA, which reminds us about which trig function goes with the opposite sides, the adjacent sides, and the hypotenuse. Looking at where my 50-degree angle is, y is the opposite side, x is the adjacent side, and 5 is my hypotenuse, in case you need that reminder. Now we're going to have to do trigonometry twice because I can't do x and y at the same time. So first I am going to find my x value. So for x, that is my adjacent, and I have my hypotenuse. So that tells me I am going to use cosine. So to find x, we are going to write an equation that says cosine of 50 degrees equals our adjacent side x over our hypotenuse 5. And we have been doing trig for several weeks at this point. So from this, you might not need quite as many baby steps, but we're going to multiply both sides by 5 so that we can get x by itself. And so in our calculators, after we have double checked that we are in degree mode, we are going to do 5 times the cosine of 50 to give us x. So 5 times the cosine of 50 in my calculator gives me x equals 3.21393 and some change. Now remember, we always keep all of our decimals until the very end, just in case we need to use it for another step, or we need to use more than just the tenths place. We don't want to round until the very end. So that gives us our x value. And then we're going to find our y value. So to find y, I'm going to think back to y is the opposite side and 5 is the hypotenuse. I always try to use the hypotenuse each time if I know it. I don't want to use the new x that I found because I want to make sure I'm using all of the decimals possible. Using 5 is much easier than typing 3.213, all of that into the calculator. So for the opposite and hypotenuse, we are going to use sine. So sine of 50 degrees equals the opposite, which is our y value, over our hypotenuse, which is 5. We can do the same step mathematically, multiplying by 5 on both sides. On the right-hand side, those will cancel out. So on the left-hand side, we have 5 times sine of 50 equals y. And so in my calculator, 5 times sine of 50 gives me back 3.83022222156. So now that I know my x and y value, I want to give myself the final correct answer. So A prime is the point we are trying to find. The last thing you want to double check is what quadrant is your new point in? Are you in the first quadrant, second, third, or fourth? We have to remember our signs. Are they positive or are they negative for x and y in that quadrant? So as a quick reminder, in quadrant 1, which is the upper right quadrant, we get positive and positive. Traveling counterclockwise in quadrant 2, we have negative x and positive y. Going down, quadrant 3, we have negative and negative for both. And then lastly, quadrant 4, we have a positive x, and a negative y. So since A prime is in that first quadrant, both will be positive. And we're going to say to round this to the nearest tenth. We don't want a ton of decimals. So we're just going to round to one decimal place. So my final answer for A prime will be at 3.2, 3.8.